Welcome back, everyone. We're going to be solving LeetCode 270, closest binary search tree value. So we're given the root of a binary search tree and a target value. We need to return the value in the tree that is closest to the target. So we're given a tree of 4, 2, 5, and 1, 3, and a target of 3.71. All right, we should return the node value of 4 because that is the closest value to our target, right? So we're working with a tree, so we're going to have to use some sort of traversal algorithm. I am going to use a breadth-first search. All right, so I'm going to import our queue from our collections library. So from collections, import dq. Okay, now let us get that queue set up, dq, and we will add the root on. We're also going to have some sort of way to check how close a node's value is to the target, right? So let's set up a variable called difference, and we will initially set it equal to the float value of positive infinity. And let's do the same for the node value that we want to return, right? Because not only do we have to keep track of the difference, they want us to return the node value. So we're going to remember the node value whenever we update this difference. We'll also update this node value. So we will also set this one to float of positive infinity. And we will run this loop, right? We want to traverse all the nodes and find the closest difference. So we'll say while the length of our queue is not equal to 0, meaning we still have nodes to traverse, we are going to say our current node is going to be queue.popleft. Now we're going to check and make sure that that node is non-null. We do that by saying if node is not none, what do we want to do? We want to calculate the difference value. And we are going to say it is going to be the absolute value of our target minus our node value. Now, what do we want to do? We want to potentially update our difference. And we can do that by saying if the difference is greater than, well, what are we looking for? We are looking for the minimum, so it should be less than. If the difference is less than the current difference, and let's just say, what do we want to do here? We could just say this. This will make it easier. So if the absolute value of the target minus the node.value is less than the difference, then we want to potentially update our difference. Fix some spacing here. Okay, now what do we want to do? Whenever we update this difference, we also want to keep track of the node value that we just calculated the difference from. So we can set node equal to node.val, and let's change this to result node, so we're not reusing variables. Okay, now once we've done this, or potentially have done this, we still need to traverse the rest of our nodes, right? So now we just need to check if node.left is non-null. We need to add it to our queue. And we need to do the same thing for the right node. Right and right. Okay, now we should be able to return the resulting node's value. And let's get rid of some spaces here. We'll run this. And it does pass both test cases, so let's submit. Perfect, it passes the submission tests. Awesome. So what is the time and space complexity for this problem? The space complexity is going to be bound to the length of our queue, right? It can grow to the length of however many nodes we have. So that is going to be O of n. And the space, or the time complexity, is going to be Let's see here. It is going to be O of n, where n is the number of nodes we have to traverse. All right, that'll do it for LeetCode 270.